So now let me introduce to my team, myself Chirag Kaura from ECE2 subgroup.
My name is Gagandeep Singh and I am from EC4 subgroup.
Myself is Pratham and I am from ENC5 subgroup.
My name is Ayush Pundir and I am from EC3 subgroup.
Hello, my name is Gunjot Singh and I am from EC2 subgroup. Good morning. Drones helps us to fly. Drones help us to growth. Basically, drones are the future. Taking this thought in our mind, we have designed our capstone on the topic autonomous drone simulation. The objective of the project is to design a proportional integral derivative based controller in MATLAB Simulink to achieve the altitude and the motion control of our autonomous drone.
Now moving on to our project overview. Our project aims to develop a simulation for an autonomous drone system. The simulation will allow testing and evaluation of the drone autonomous capabilities in various scenarios without the need of physical hardware. The ultimate goal is to define and improve the drone autonomous navigation, obstacle avoidance, and mission planning algorithm. The trajectory planner converts the high-level mission plan into a series of waypoints and paths for the drone to follow. MATLAB Simulink is used to design and implement trajectory planning algorithms taking into account factors such as obstacle avoidance and optimization of flight time.
Now the question arises, why is the need of a virtual drone? Simulation provides a controlled and safe environment for training and testing autonomous drone. Instead of risking real-life drone operation, simulation allows developers and operators to validate their algorithms, evaluate performances, and identify the potential issues before deploying the drones into the field. Drones operating autonomously need to navigate complex environment, avoid obstacles, and make critical decisions. And best part of this is it is cost efficient. Building and operating physical drones for testing and training can be expensive. Simulation provides a cost-effective alternative by eliminating the need for physical hardware maintenance and potential damage. Now, this slide shows you how we approached to our capstone model. First of all, we designed our drone model design since our simulation was software, so it was designed using MATLAB. Then we created a virtual environment which included gravity, resistance, and the drag force, which controlled the motion of the drone. Since I explained earlier, our control module was the MATLAB Simulink, which controlled our motion of drone in helical path. Then we planned various algorithms like mission planning algorithm, obstacle resistance algorithm, which are the part of our drone simulation. Finally, we integrated all our algorithms and the equations and the laws of motion into one equation, which gave us the final trajectory of how our drone simulation works.
This slide shows us our learning from this project. We understood the fundamental of autonomous drones, including their component, sensors, and actuator, learn about flight dynamics, navigation system, and how drones perceive and interact with the environment. We also learned drone control and navigation, studied the principle of drone control navigation algorithms, learn about techniques such as PID control, path planning, obstacle avoidance, understand how these algorithms can be implemented and tested within the simulated environment.
So this is the much awaited final model, or you can say final trajectory of how our drone looks like. So you can see the Euler angles and the XYZ continuously changing, and the velocity of the drone is continuously changing at each timestamp. This controller is built upon the mathematical model of kinematics and dynamics of the vehicle. The simulation results of the design model were quite satisfactory. On the real-time MATLAB, we could lift the quadcopter from the ground while moving in the helical path and achieve the stability for hovering. During this process, we have introduced various kinds of forces like drag force, gravity force, and viscous force, which has helped in our motion of the drone. I hope you liked our presentation. Thanks for your patience. I hope you liked our capstone presentation.